Welcome back to QHSE Talks. Imagine a worker on a Tuesday afternoon, just a regular Tuesday.
Right, just going about their shift.
Yeah, exactly. Let's say she's on an assembly line, and as she clocks out, she rubs her shoulder.
Just a little sore, I imagine.
Yeah, exactly. It's just a little sore, nothing crazy. She figures, well, I probably just slept on it funny, or maybe I pushed a little too hard during that final hour of the shift.
Which is such a common thing to think.
Right. But then, by Thursday, that slight soreness is a sharp twinge every single time she reaches above her head.
Oh, that's not good.
No, it's not. But she doesn't say anything because, well, nobody wants to be the complainer on the floor.
Right.
And she needs the overtime.
Right, there's always that pressure to just push through it.
Always. So, fast forward 6 months. That unspoken twinge has evolved into a fully torn rotator cuff.
Wow, and that is a massive issue.
We're talking a $150,000 workers' compensation claim, a permanently altered quality of life for this worker, and, a vacant spot on the floor that throws the entire production schedule into absolute chaos.
It's a complete downward spiral from one little ache.
Exactly. So today we are undertaking a comprehensive analysis of the exact mechanisms that can prevent that entire downward spiral.
I love this topic because, well, we are looking at a space where human physiology, behavioral psychology, and industrial engineering all just kind of collide.
They really do. And for those of you who tune in to expand your mastery of quality, health, safety, and environment, we're specifically looking at the Associate Safety Professional, or ASP, exam blueprint today.
Yes, specifically zooming in on Domain 3.
Right, Domain 3, which covers ergonomics. Now, this domain makes up a very solid 8% of your exam.
It's a significant chunk.
Absolutely. It is. But we aren't just skimming the surface of the whole domain here. We're focusing intensely on topic 6, which is identifying ergonomic work practice controls.
Which, I have to say, is a particularly vital area. I mean, it is the actual tactical application of safety.
It's where the rubber meets the road.
Exactly. We are going to look at everything from, the physiological realities of job rotation to that absolutely critical window of early symptom intervention.
And even some sci-fi sounding stuff, right?
Yeah. We're even going to get into how frontier technologies like exoskeletons are just fundamentally changing how we define work practice.
I am so excited for that part. But first, I want to speak directly to you, the listener, for a moment.
Oh, for it.
Whether you are actively hitting the books, running those flashcards, and studying to pass the ASP exam, or, maybe you are a seasoned safety professional just looking to refine your on-the-job effectiveness, mastering these specific controls is an absolutely essential skill.
It really bridges that massive, sometimes treacherous gap between theoretical textbook knowledge and keeping real people safe on the floor every single day.
Right, because you can memorize all the anatomical charts you want,
Oh, sure. You can know the exact tensile strength of a human tendon.
But if you don't actually know how to implement these workplace practices, well, the scientific knowledge isn't doing anyone any good.
It's basically the difference between knowing why a bridge collapses and actually directing the traffic to keep the stress load off the weakened beams.
That is a great way to put it.
Thanks. I mean, ergonomics on paper is just anatomy and physics, but ergonomics in practice, that is management, communication, and strategy.
Absolutely. So let's unpack the core philosophy of ergonomics and work practice controls. I was looking through the source material, and it brings up the etymological origin of the word itself.
Oh, right, the Greek roots.
Yeah. It comes from the Greek words ergon, which means work, and nomos, meaning law, so the laws of work.
I always love that definition. And when we talk about the laws of work, we aren't talking about, human-made laws like a company's HR policy or some union contract.
Right, it's not administrative rules.
No, we are talking about the physical, physiological, and biomechanical laws that actually govern the human body when it is engaged in labor.
Things like gravity and leverage.
Exactly. Gravity, leverage, tissue tolerance, metabolic fatigue.
Yeah.
These are immutable laws. You literally cannot negotiate with gravity.
Try as we might.
Right. And you can't just ask a tendon to, simply endure more friction than its biological limit allows. It just snaps.
Which means the fundamental principle of this entire discipline is that the job must be adapted to the person, rather than forcing the person to fit the job.
Yes. And historically speaking, that is a massive paradigm shift.
Yeah, huge. I mean, if you look back at the early days of the Industrial Revolution or even those scientific management theories of the early 20th century, the philosophy was entirely the opposite.
Completely backward by today's standards.
Right. The machine was the expensive, unchangeable, precision-engineered asset. And the human worker.
They were viewed almost as a replaceable biological motor.
Exactly. They just had to contort themselves to operate the machine.
And we paid a terrible societal and economic price for that philosophy, frankly.
Generations of workers just broken down.
Yeah, we saw generations of workers suffering from severe cumulative trauma, musculoskeletal disorders, and permanent disabilities. And it was all simply because the workstation was designed for the machine's efficiency rather than the human's longevity.
It's pretty grim when you think about it. But modern ergonomics flips that script entirely, doesn't it?
It absolutely does. The worker is now, correctly, viewed as the fixed biological entity with highly specific, measurable limits.
So we can't change the human.
Right. It's the work environment, the hand tools, the software interfaces, and the daily processes that must be molded around those human limitations and capabilities.
Okay, but wait, let me play devil's advocate here for a second based on the exam material.
Sure, lay it on me.
If we look at the hierarchy of controls, which is, the safety professional's absolute holy playbook for mitigating risk, we have a very specific ranking.
We do. Elimination at the top.
Right. We start with elimination and substitution, then we move down to engineering controls, and then below that, we have administrative or work practice controls.
Correct.
And the exam materials explicitly state that administrative controls are ranked as less effective than engineering controls.
They are, structurally speaking.
Because the reasoning provided is that they rely heavily on employee compliance, supervision, and just the inherent unpredictability of human nature.
Humans are messy, yeah.
Right. So if they're structurally the least reliable way to control a hazard, why on earth are we dedicating an entire section of the ASP exam to mastering them?
That's a very fair question.
I mean, why wouldn't a safety professional just focus 100% of their energy on engineering every single hazard away so human behavior doesn't even factor into it?
Well, in a utopian scenario, with infinite capital and infinitely flexible infrastructure, we would absolutely engineer every hazard out of existence.
Just automate everything.
Exactly. If a worker has to lift a heavy component, we would just install a beautiful automated pneumatic lift assist that does all the work for them.
Sounds great.
It does, but the reality of industrial economics and operational constraints paints a very, very different picture. Engineering controls aren't always immediately viable.
And sometimes they aren't viable at all.
Precisely.
Walk me through those barriers. I mean, is it primarily just the price tag?
Cost is a massive barrier, certainly. I mean, a fully integrated robotic lifting system might require a multi-million-dollar capital expenditure.
Oh, wow. Yeah, that's not petty cash.
No. And that requires board approval, a long procurement process, custom engineering, and an entire facility shut down just for the installation.
That sounds like a nightmare to schedule.
It can easily take 2 to 3 years. But you have 3 shifts of workers on the floor today who are currently bending and twisting to move that product.
Right. They are getting hurt right now.
Exactly. You cannot simply tell them to hold their breath and try not to get injured for 3 years while the robots are being built.
So you need an immediate stopgap.
Precisely. And beyond just cost, there is the issue of legacy infrastructure.
What do you mean by that?
Well, many manufacturing plants, chemical refineries, or logistics hubs are operating in facilities built 40 or 50 years ago.
Oh, sure. Old buildings.
Yeah. The physical footprint, the ceiling height, or even just the floor load capacity simply might not support the installation of modern ergonomic hoists or massive conveyor systems.
You are physically constrained by the building itself.
You are.
And what about the actual nature of the work? I imagine there are tasks where a machine just can't do what a human hand can do.
That's the third major barrier, task complexity. Consider a maintenance worker who has to reach inside the cramped chassis of a commercial aircraft to rewire a very specific instrument panel.
Oh, that sounds incredibly tricky.
It is. There is no engineering control that can replace the tactile feedback, the micro adjustments, and the on-the-fly problem-solving of a skilled human technician in that space.
Because the space is so tight and the work is so delicate.
Exactly. You cannot engineer the hazard out because the human presence is the defining requirement of the task.
So the idea that we can just automate our way out of all ergonomic hazards is basically a myth.
It is a complete myth.
Yeah.
Regulating the human performance aspect through workplace rules, specific operational procedures, and intelligent scheduling becomes the immediate and frequently the only line of defense.
It's the crucial bridge.
Right. Administrative controls are vital because they manage the exposure to the hazard when the hazard itself cannot be removed.
So they keep people safe while you are waiting for that engineering control to be implemented.
Or they act as the necessary supplement to an engineering control that doesn't mitigate 100% of the risk.
Ah, right, because machines aren't perfect either.
Exactly. I mean, think of a fume hood. A fume hood is an engineering control, right?
Right.
But the rule that a worker must keep their face outside the sash of the hood, that is a work practice control. One veils without the other.
That layered defense strategy makes perfect sense. So let's look at how that actually translates into daily operations on the floor.
Let's do it.
The source material highlights one of the most common, yet I think most frequently misunderstood, work practice controls, and that is job rotation.
Job rotation is the quintessential administrative control. I mean, the core definition is pretty straightforward.
How does the exam blueprint define it?
It defines it as the systematic, scheduled movement of employees from one job or task to another.
Okay, simple enough.
And the primary goals are to reduce an individual employee's duration of exposure to specific physical hazards, to provide the workforce with a broader range of skills through cross-training.
Which is always good for business.
Definitely. And finally, to alleviate the sheer psychological monotony of highly repetitive work.
Let's look at some of the concrete examples provided in the text to really ground this for you listening.
Sure, let's start with manufacturing.
Okay, so in a manufacturing setting, you might have a worker whose primary role involves handling hazardous chemicals.
So the environmental exposure there is very high.
Right, and perhaps the physical demand of moving those heavy chemical drums is high too.
So what do we do?
A strategic job rotation would move them away from the chemical handling after, say, 4 hours and place them in a packaging or quality control role for the second half of their shift.
Perfect. Or consider an agriculture worker.
Oh, yeah. Agriculture is brutal on the body.
It really is. They might spend the entire morning out in the fields, exposed to the intense physical demands of stooped harvesting, plus the environmental hazards of extreme heat and ultraviolet radiation.
So how do you rotate them?
A properly designed rotation would transition them into an indoor climate-controlled office or laboratory setting for the afternoon, perhaps processing agricultural data or inspecting samples.
That makes total sense.
Yeah.
And in construction, it could mean taking a worker who has been performing really intense repetitive overhead work, like drilling into a concrete ceiling or installing HVAC ductwork.
It destroys your shoulders.
Yeah, exactly. And you rotate them to a completely different phase of the project site. Maybe they go do some ground level framing or material inventory, which utilizes completely different physical movements.
Now, all of those sound excellent on paper.
Right, they sound like easy fixes.
But there's a massive physiological caveat that the source material highlights.
Yeah.
And it is a trap that organizations fall into constantly.
The false rotation trap.
Exactly. Moving a worker from one workstation to another workstation does not automatically constitute a successful job rotation.
Because it's not just about a change of scenery.
No, the entire biomechanical purpose is that you must allow specific muscle groups to rest.
So what does a textbook false rotation look like?
Okay, picture this. You have a production line worker whose morning job requires high-intensity shoulder activity.
Okay.
Let's say they are lifting 10-pound components from a waist-high bin up to a shelf slightly above shoulder height over and over and over.
My deltoids hurt just thinking about it.
Right. So management decides to implement job rotation, feeling very proud of themselves. After lunch, they move this worker to a different station.
Sounds good so far.
But at the new station, the worker is operating a pull-down lever to actuate a press.
Oh. So they are still heavily engaging the deltoids, the trapezius, and the rotator cuff.
They are using the exact same muscle groups. The specific task looks different, the product is different, the tool they are holding is different.
But the biomechanical load is nearly identical.
Exactly. You have completely defeated the purpose of the rotation. You haven't mitigated the risk of a musculoskeletal disorder at all. You have merely changed the scenery while continuing to compound the fatigue on the exact same tissues.
You know, it makes me think of designing a gym routine.
Oh, that's a good analogy.
Yeah, like you don't follow up a really heavy upper body workout with another upper body exercise.
No, you'd be exhausted.
Right, you switch to leg day so the arms can actually recover. Job rotation has to be basically muscle group rotation.
That is a phenomenal way to visualize it. And if we connect this back to the daily duties of a safety professional, it reveals exactly why you cannot implement a job rotation program from a spreadsheet in a corporate office.
You can't just look at a list of names, glance at the job titles, and swap people around.
No, It requires a massive amount of preliminary on-the-ground analysis.
So what is the safety pro actually looking for?
They must rigorously review the physical demands of every single task involved in the rotation pool. What specific muscle groups are engaged? Are we dealing with static loading or dynamic loading?
You have to know the frequency of the repetition, the required force.
Yes. Furthermore, you have to review the cognitive demands of the tasks.
Wait, how do cognitive demands factor into an ergonomic evaluation? I usually associate ergonomics purely with physical strain, lifting boxes.
Most people do, but the human body doesn't operate in silos. The nervous system connects everything.
Right.
High cognitive demand tasks requiring intense concentration, rapid decision-making, or complex problem-solving induces mental fatigue.
And mental fatigue affects the body.
Heavily. Mental fatigue frequently manifests as physical fatigue. Moreover, a lapse in concentration due to cognitive overload can lead to a direct breakdown in physical technique.
Oh, I see.
If a worker is mentally exhausted from a highly complex quality assurance task, and you rotate them to a heavy lifting task right after,
their brain might not be sharp enough to maintain that necessary neutral spine posture.
Exactly. Which leads to an acute physical injury.
Wow. So you are balancing a biological budget of both physical and mental energy.
Yes, and you have to balance all of this with the realities of production, too.
Right. Like, does the worker actually have the required safety training and operational certification to operate safely at that second station?
Exactly. Does the rotation schedule disrupt the upstream or downstream workflow?
Which is why true, effective ergonomic job rotation is a highly complex puzzle.
It requires a deep understanding of biomechanics, a clear grasp of cognitive workload, and a seamless partnership with the operations managers.
Okay, so let's follow this progression. Even with a perfectly optimized job rotation schedule, human tissue still experiences wear and tear.
It does. Microtrauma still occurs no matter how good your rotation is.
Right. So what happens when the physical demands outpace the body's ability to recover?
That brings us into the absolute heart of the ASP Blueprint Topic 6, early symptom intervention.
This is such a big deal.
It is arguably the most critical juncture in the entire occupational health timeline. The text specifically highlights the use of symptom surveys.
What are those exactly?
They are structured tools used to proactively ask workers to self-identify physical issues. It allows the safety professional to gauge the imbalance between the demands of the work and the capabilities of the worker before a catastrophic failure occurs.
And this is so necessary because the statistic in the source material regarding this is just staggering.
It really is.
It states that as many as 50% of workers do not report their musculoskeletal disorders or work-related illnesses.
Half. Half of the workforce is walking around in pain, experiencing physical degradation, and remaining completely silent about it.
It represents a massive systemic failure in workplace culture and communication.
It does. And to truly understand why early intervention is the linchpin of ergonomics, we have to look really closely at the physiological threshold between transient discomfort and actual pathological pain.
Because they aren't the same thing.
Not at all. The text details how it is incredibly common for workers to experience mild to moderate discomfort near the end of their shift.
Sure, they have been engaged in physical labor for 8 or 10 hours.
Right. Their muscles are depleted of ATP, lactic acid is accumulated, and they feel a dull ache. But the critical distinction is that usually this ache disappears by the next day.
The body's natural repair mechanisms just work overnight while they sleep.
Exactly.
So the worker wakes up the next morning feeling fine, and they internalize a narrative.
What do they tell themselves?
They say, oh, it's just part of the job. It's an honest day's ache for an honest day's work. I'm just tired. And because they feel recovered, they just ignore it.
They ignore it because it resolves. It is a biological false positive, essentially.
False positive, yeah.
But over time, if that mismatch between the job demand and the worker's capability continues unchecked, the nature of the damage actually changes.
The inflammation begins to compound.
Yes. The micro tears in the tendons do not fully heal before the next shift begins. That mere discomfort escalates into a sharp, persistent pain.
And when the intensity changes from discomfort to actual pain, that's bad.
It is a biological alarm bell, signaling that the tissues have lost their ability to recover during the standard time away from work.
The overnight rest, the weekend off, it's no longer sufficient to heal the trauma.
You are now running a physiological deficit. The inflammation becomes chronic. The muscle fibers begin to develop scar tissue instead of healthy new tissue.
And once a worker crosses that threshold from discomfort to persistent pain,
they're on a rapid, incredibly difficult to reverse downward trajectory toward a complete loss of physical function.
Which is exactly what leads to lost productivity, mandatory modified duty, extended sick time, or long-term disability.
Exactly.
The challenge then is catching the whisper of discomfort before it becomes the scream of a torn tendon.
I like that phrasing, catching the whisper.
How do you, as a safety professional, actually build a culture where a worker feels comfortable raising their hand over just a minor ache?
It's tough.
Because the text explicitly mentions that workers fear reporting. What are the actual drivers of that fear in an industrial setting, and how do we dismantle it?
The fear is multifaceted, and it's deeply ingrained in the sociology of many workplaces. Frequently, it is driven by a macho, stoic culture.
Oh, absolutely.
If you're on a construction site or an oil rig, nobody wants to be perceived as the weak link complaining about a sore wrist when everyone else is just quietly gritting their teeth and working through it.
There is immense peer pressure to endure, the fear of ostracization from the group.
Exactly that. And then there's the fear of administrative retaliation.
Which is very real for a lot of folks.
It is. Workers worry that if they report a symptom, management will view them as a financial liability. They fear they will be taken off a lucrative overtime shift, demoted to a less desirable task, or ultimately managed out of the company.
And finally, there's just the fear of the bureaucracy itself.
Oh, paperwork.
Right. Many workers have seen a colleague report an injury and get tangled up in endless HR paperwork, mandatory clinic visits, and workers' compensation investigations.
And they decide they would rather just take some ibuprofen and avoid the headache.
So they stay silent, popping over-the-counter painkillers until the wrist joint completely gives out while they are holding a heavy power tool.
Which is the worst possible outcome for the workers' health, the safety of their colleagues, and the financial health of the company. If a safety professional can build a genuine culture of trust, a psychological environment where a worker can say, hey, I've noticed my forearm is really throbbing at the end of the line lately, the entire paradigm shifts.
Because then you can implement a proactive, low-cost intervention.
Exactly. You investigate the actual work process. You observe them at their station.
And what might you find?
You might discover that the workbench is 2 inches too high for their specific stature, forcing them to constantly shrug their shoulders and compress the nerves in their neck.
Or you might find that the pneumatic tool they're using hasn't been serviced and is excessively vibrating.
Right. So you fix the height of the bench, you swap out the tool, you apply that job rotation we just discussed.
You eliminate the root cause of the microtrauma before the tissue damage becomes permanent.
Yes. And the financial implications of that are staggering.
A minor adjustment to the height of a work table or replacing a $50 anti-vibration glove costs practically nothing.
But a fully developed permanent musculoskeletal injury, one resulting in surgery, months of physical rehabilitation, and a massive workers' compensation settlement.
That can easily cost a company hundreds of thousands of dollars.
Not to mention the devastating, unquantifiable impact on the workers' quality of life and their ability to play with their kids or enjoy their retirement.
The financial ROI of early intervention is just astronomical.
The success of early symptom intervention is directly, inextricably linked to the success of the overall ergonomic safety process. It is the canary in the coal mine for your entire safety program.
This emphasizes a crucial reality for anyone taking the ASP exam. Safety isn't just about inspecting hard hats and writing lockout, tagout procedures.
No, it's heavily reliant on interpersonal communication, building trust, and shaping behavior.
Which naturally transitions us into the next massive component of the ASP Blueprint Topic 6, training, technique, and the human performance factor.
We established earlier that administrative controls rely heavily on human behavior, right? Well, formal training and ongoing education are the primary tools a safety professional uses to attempt to shape, standardize, and reinforce that behavior. Training functions as a foundational work practice control.
And the blueprint and the source material are very specific about the nature of this training.
It is not just handing out a pamphlet.
No. It's not a pamphlet that says, be careful, or hanging up a poster in the break room that says, lift with your legs.
Those don't work.
No, they don't. It is about teaching highly specific, correct work methods that actively mechanically minimize physical demands.
The text gives a great example of this.
Yeah, teaching a worker to consciously, lightly contract the supporting muscles of the abdominal core and spine prior to initiating a heavy lift, ensuring they keep the lumbar spine in a neutral, stabilized position.
You are essentially teaching applied biomechanics to the workforce.
Right.
The goal of this training is to establish safe motor patterns.
Let's define that. What is a motor pattern?
A motor pattern is a neurological pathway in the brain. It is the biological basis of muscle memory. When a highly experienced veteran worker performs a task for 10 or 15 years, they naturally and sometimes entirely unconsciously find the path of least physical resistance.
Just through trial and error over the years.
Exactly. They figure out the subtle shifts in body weight, the specific grip angles, and the exact timing required to minimize the impact of the hazards on their body. They learn how to survive the shift.
They learn all the subtle, unwritten tricks of the trade that aren't in the official manual.
But new hires lack these established protective motor patterns. They don't know the tricks yet.
Right. They're just coming in cold.
When faced with a physically demanding task, a novice relies purely on brute muscular force rather than mechanical leverage.
Which is so dangerous.
It puts them at a massively elevated risk for an acute, sudden injury during their first few weeks on the job.
And this is why proactive, highly detailed ergonomic training is so crucial.
You cannot ethically or financially afford to wait for them to figure it out on their own through painful trial and error.
You have to train new hires from day one, explicitly instilling those safe motor patterns before bad, dangerous habits take root. But let me push back on the reality of that training process for a second.
Okay, go ahead.
Suppose I am a mid-career hire, okay? I've been working in warehouses for a decade, and I've been lifting heavy boxes with a rounded back and an awkward twisting posture my entire adult life.
Your body's very used to that.
Right. My nervous system is deeply hardwired to execute a lift the wrong way. A standard 45-minute classroom training session, complete with a PowerPoint presentation and a multiple-choice quiz, is absolutely not going to rewire a decade of established neurological pathways.
No, it definitely won't.
The moment I get out on the floor and the production speed ramps up, my brain is going to immediately default to the old dangerous habit.
Your assessment is entirely accurate, and the source material actually acknowledges this exact difficulty.
Well, it does.
Yes. Unlearning a deeply ingrained physical habit requires immense conscious cognitive effort and constant daily reinforcement.
So a classroom session in isolation is basically practically useless for changing long-term physical behavior.
Pretty much. This is why the initial training must be paired with continuous on-the-floor observation, peer-to-peer coaching, and another crucial administrative control detailed in the blueprint: work pacing.
Work pacing. Okay, how does managing the speed of the work actually function as an ergonomic control?
Well, if you know an employee is struggling to maintain proper biomechanical form, whether because of ingrained bad habits they're trying to break, or simply because the task itself is inherently demanding, you must manage their duration of exposure to that demand.
That makes sense.
Work pacing involves intentionally structuring the flow of the job to avoid continuous high repetition and to break up prolonged static postures.
Let's define static postures for a moment, because we usually think of work injuries coming from movement, right? Like lifting, twisting, swinging a hammer.
But static posture is when a worker is holding a position without moving at all.
Like an assembly worker holding their arms out in front of them for hours.
Or a lab technician bending over a microscope, holding their neck in a fixed downward angle.
From a physiological standpoint, static loading is incredibly destructive, isn't it?
Oh, it's terrible.
Yeah.
When a muscle is actively engaged in a static posture, it remains in a state of constant contraction.
Right.
This continuous tension physically clamps down on the capillary beds within the muscle tissue.
It's squeezing the blood vessels.
Exactly. It creates a state of localized ischemia, meaning the blood flow is severely restricted.
And because blood flow is choked off.
The muscle is starved of oxygen, and it cannot flush out the metabolic waste products like lactic acid.
The tissue is essentially suffocating in its own waste.
That's a graphic but very accurate way to put it. The fatigue sets in rapidly, the muscle begins to tremor, and then the surrounding joints and tendons have to take on the structural load, which leads to severe strain.
So how does pacing fix this?
Intelligent work pacing interrupts this destructive cycle by introducing short, mandatory rest breaks.
And in this context, rest doesn't necessarily mean sitting down in a chair and drinking coffee, does it?
No, it means active recovery. It means standing up, stretching the opposing muscle groups, and moving around to release that capillary restriction.
To forcefully flush the ischemic tissues with fresh, oxygenated blood.
Exactly.
Yeah.
It also involves deliberately mixing in non-computer tasks or offline tasks to encourage the use of completely different physical systems.
So if a worker is performing highly intense, visually demanding microassembly work that requires a rigid, hunched posture,
Pacing might dictate that every 45 minutes they must stop the assembly and spend 10 minutes doing inventory.
or sweeping their area, or walking across the facility to restock supplies.
Yes, it shatters the cycle of static repetition.
And the text also highlights the use of stretching and warm-up programs as a component of work pacing and training.
It does, but there is a massive caveat here, similar to the job rotation trap we talked about. These programs cannot be implemented blindly as a generic corporate-wide initiative. A safety professional must carefully evaluate the specific physical demands of the jobs before implementing any stretching routine.
Because the wrong stretch could actually exacerbate the strain.
Think about it mechanically. If a logistics worker just spent 4 hours hyperextending their lower back while loading pallets,
Forcing them to participate in a generic, mandatory stretching routine that involves further backward bending could actually trigger the exact acute injury you were trying to prevent.
exactly. The warm-up must be scientifically tailored to prepare the specific muscles for the specific tasks, and the cool-down stretching must be designed to relieve the specific tensions generated by the shift.
There is absolutely no one-size-fits-all solution in ergonomics.
None. It requires constant, vigilant, customized assessment.
That level of customization brings us perfectly into the final section of our exploration today, which covers advanced controls, PPE, and the ultimate responsibility of the worker.
This is where things get really futuristic.
I know, I was genuinely struck by a specific technological inclusion in the ASP blueprint for Topic 6. Amidst all the discussions of work pacing and training, it explicitly lists exoskeletons.
It is a remarkable indicator of where the field is heading. The blueprint officially categorizes exoskeletons as an ergonomic work practice control.
It is fascinating to see exoskeletons grouped right alongside traditional concepts like job rotation.
It really shows how rapidly the occupational safety field is evolving.
We are moving way beyond just telling someone to take a break or lift with your legs, and we are beginning to utilize advanced wearable structural support.
It really feels like this technology is completely blurring the traditional boundary between an administrative work practice and personal protective equipment.
It is the absolute frontier of occupational safety and industrial hygiene.
For those who might not have seen one, exoskeletons are wearable devices designed to work synchronously with the user.
Right. If a robot is designed to replace the worker, an exoskeleton is designed to augment and protect the worker.
Exactly. And they generally fall into two categories: active and passive.
What's the difference?
Active exoskeletons utilize power sources, motors, and complex sensors to provide actual mechanical force to assist a movement.
Like Iron Man.
Essentially, yes.
Yeah.
Passive exoskeletons, which are currently much more common in the workforce, do not use motors.
How do they work then?
Instead, they use a highly engineered system of springs, dampeners, and counterweights to redistribute the weight of a load or the weight of the worker's own limbs.
Let's visualize how a passive system actually works biomechanically for the listeners.
Okay, suppose you have a worker who spends their entire shift doing overhead work on an automotive assembly line, constantly using a heavy torque wrench above their head.
Without support, the entire weight of their arms and the weight of the heavy tool is bearing down on the small, delicate structures of the rotator cuff and the cervical spine.
It is a recipe for rapid fatigue and chronic injury.
Right.
But a passive upper body exoskeleton changes the load path. When the worker lowers their arms, the springs in the exoskeleton compress, capturing that kinetic energy.
Oh, that's clever.
And when they raise their arms back up to work, the springs release that energy, pushing upward.
So the device effectively neutralizes the weight of the limbs and the tool.
Yes, transferring that physical load away from the vulnerable shoulders and routing it down through a rigid harness frame directly into the worker's hips and the floor.
It fundamentally alters the physical demand of the task, dramatically lowering the fatigue rate and extending the worker's safe operational endurance.
It's incredible technology.
But speaking of wearable gear, you mentioned personal protective equipment, or PPE, earlier.
Yes.
The text makes a really strong point to discuss how standard PPE heavily influences ergonomics, which is a factor I think a lot of people overlook when they are just trying to meet a basic compliance checklist.
It is a frequently missed connection. We usually think of PPE like hard hats, respirators, and chemical suits purely as the solution to a hazard.
Right, it protects you from the bad stuff.
But poorly designed or poorly fitting PPE can actively introduce a severe ergonomic hazard all on its own.
How does the fit of the gear actually change the biomechanics of the job?
Through restriction and the amplification of required force. The physical fit of PPE and work clothing is a critical ergonomic variable.
Give me an example.
Consider a worker who is required to wear a heavy, impermeable chemical protective suit.
Okay, those are bulky.
If that suit is even slightly too small or poorly articulated at the joints, it physically restricts the worker's natural range of motion.
So the worker now has to physically fight against the stiffness of the suit just to bend their elbow or reach for a valve.
Exactly. This significantly increases the metabolic and muscular force required to simply move their own body through space, which severely accelerates fatigue.
And what about something as simple as gloves? I mean, everyone wears gloves.
Gloves are a prime example. If a worker is wearing cut-resistant or thermal protective gloves that are excessively thick.
Or if they were wearing a size too large, right?
Yes. The glove material bunches up and severely reduces tactile feedback. The worker can no longer feel the tool securely in their hand.
So what happens?
Consequently, the brain subconsciously commands the hand to squeeze tighter to ensure the tool doesn't slip.
Oh, wow.
A poorly fitting glove can force a worker to exert 20 to 30% more grip force than they would barehanded.
Which absolutely skyrockets the risk of developing repetitive strain injuries, tendinitis, or carpal tunnel syndrome in the hands and forearms.
All because the glove didn't fit right.
That's crazy.
And it applies to everything. A poorly fitted fall protection harness can cut off circulation to the legs when moving.
Heavy steel toe boots that do not support the worker's specific arch type can alter their natural gait,
which forces compensatory movements that eventually lead to chronic knee degradation and lower back pain.
Therefore, ensuring the proper sizing, fit, and articulation of all PPE is not just a comfort issue, is it?
Not at all. It is a fundamental, required ergonomic work practice control.
So we have talked extensively about what the safety professional does in analyzing the data. We have talked about how management designs the rotation schedules and funds the equipment.
We've talked about the physical environment.
But the source material makes a very intentional pivot at the very end of this topic to discuss the individual worker's role in all of this.
Which is so important.
A truly successful ergonomics program cannot simply be a top-down mandate dictated by corporate, can it?
It absolutely cannot. A top-down only approach is doomed to fail. A sustainable safety culture requires active, engaged, and continuous worker involvement.
Because you can purchase the most advanced exoskeleton on the market.
You can design the most meticulously balanced, biomechanically perfect job rotation schedule.
And you can engineer the perfect workstation.
But all of that capital and planning is entirely useless if the workforce refuses to participate, ignores the rotation schedule, or bypasses the safety features because they think it slows them down.
So the text explicitly outlines the specific required duties of the worker within a functional ergonomic program. Let's outline those duties. What is the worker's actual responsibility?
First and foremost, they must actively use the company's internal programs to continually review and assess their own work area.
The workers are the true subject matter experts on their specific jobs, aren't they?
They are. They know exactly where the physical pain points are, they know which tools vibrate too much, and they know which tasks cause the most fatigue far better than any safety professional sitting in an office ever could.
Their feedback is the lifeblood of the ergonomic assessment process.
Second, as we discussed at length during the intervention segment, they have an absolute duty to report the signs and symptoms of musculoskeletal disorders early.
While they are still in the discomfort phase.
Yes, before permanent damage occurs.
And third, they have to actually absorb and implement the training.
They must attend the training, yes.
Yeah.
But more importantly, they must consciously apply the biomechanical skills and knowledge acquired to their daily tasks.
They have to make the deliberate, sometimes difficult choice to utilize the neutral spine lifting technique.
To use the lift assist, or to take their mandatory micro break.
Even when they are rushed, or even when the old, dangerous way feels faster and more familiar.
It ultimately comes down to a shared accountability. The employer has a strict legal, financial, and moral obligation to provide a workplace free from recognized hazards and to provide all the necessary tools and training.
But the worker has a reciprocal ethical obligation to utilize those controls.
To communicate honestly about their physical condition and to conduct themselves in a manner that protects their own longevity.
It is a psychological contract of safety.
It is a partnership. And without that partnership, the entire structure of the hierarchy of controls simply collapses.
That brings everything we've discussed into a really unified, practical framework. Let's briefly recap the essential, multifaceted toolkit we have unpacked today for anyone looking to conquer Domain 3, Topic 6 of the ASP exam, or simply looking to make their facility safer tomorrow.
We explored the strategic, highly analytical application of job rotation,
emphasizing that the true biological goal is resting specific muscle groups and avoiding the devastating false rotation trap that merely shifts the hazard around.
We dove deep into the physiological realities of microtrauma, highlighting the absolute necessity of early symptom reporting, intervening at the transient discomfort stage to prevent irreversible catastrophic tissue damage.
We examined the continuous uphill battle of ergonomic training, noting the neurological difficulty of rewiring bad motor patterns.
And how we must utilize work pacing to break the ischemic cycle of static postures and mitigate compounding fatigue.
And we looked at So I want to leave you, the listener, with a forward-looking, somewhat provocative thought as we wrap up this in-depth exploration.
I'm interested to hear this.
If the fundamental premise of ergonomics is about adapting the job to the person and never forcing the person to fit the job, how will our entire approach to administrative work practice controls have to evolve over the next 2 decades?
That's a huge question.
As the global workforce rapidly ages, as retirement ages are pushed further back, and as the physical capabilities, limitations, and baseline health of our workers become vastly more diverse, the average human we used to design for will completely disappear.
The baseline is constantly shifting.
Exactly. How will your training, your pacing, and your technology need to adapt to protect a workforce that looks entirely different than it did 10 years ago? It is something crucial to think about as you walk the floor and look at the real people relying on your expertise tomorrow. Thank you for joining us for this comprehensive analysis. Best of luck on your ASP exam and keep up the great work keeping people safe out there.